Sections on 5.1 inverse functions. So the first part that we're going to do is we're going to do the inverse relation, which is then says that if we interchange the first and second coordinates of each ordered pair in a relationship, it produces the inverse functions. So what does that mean? So each one of these are little coordinates. It's like a little x and a y right there, right? So that's why they're in parentheses right there, and there's a comma in between it. And that's one set of a point. Then another set of a point would be 4 comma negative 2. Then a third set of a point will be negative 7, 1, and then 3.8 and 6.2. So what it means when we say the inverse function is that we actually could take the x and the y and we're going to interchange them. So we're going to switch them around. So for the inverse h, because this function is an h function right there, so if we find the inverse h, then what's going to happen is the 5 and also the negative 8 switches. So then we have is a 5 right here and a negative 8 right here because they switched for the position. So now the new x, right, this is the inverse x right there. So the inverse x was from this y right there. They're switching positions right there. Okay, same thing with this one then, 4 comma negative 2. So if we switch them, we're going to have then is negative 2 comma 4, and then the next set will be 1, negative 7, and then on decimal, same thing. We're going to just keep our decimal, 6.2 and 3.8. Okay, so that's the first set that we're going to do for the inverse. Now the next one we're going to do is that we're going to be given an equation, something like this, f of x is equal to 2x minus 3. We're going to find is the inverse. So there's another way to do that notation of inverse. It's this f right here. The only reason why it's an f is because this function is an f. So if this function was a g, then you should have as a g as well. So the little inverse right here, you'll see it this way notation, and then you also see it as a prime as well. So I'll show that later on when we do the graphing portion of it. So when we see the little negative 1, it means that's an inverse. So when we do an inverse, we're going to do the switching. So as the definition of this says that we're switching the x and y's, it's the same idea with this one right here. We're going to switch the x and y's. But it's an equation that we're switching. So we're going to go ahead and switch the equation. So the f of x right here is the same thing as y. So I'm going to go ahead and put y equals, and then we're going to go 2x minus 3. I'm just copying all of this right here. So I haven't done the inverse function yet. All I did was I switched the function of f of x to a y, because when we graph it, it's a y equals, but when we write an equation or we're dealing with functions, then we have f of x. Okay, once I have this y equals 2x minus 3, we're going to literally go ahead and switch the variables only of the x and the y. So now this becomes an x, this becomes 2y minus 3. It's the same idea as what we just did on example 1. But in this case, we're only switching variables, not the numbers, just the variables. Okay? Now, from this point on, we want to solve for y algebraically. So now this is where it gets a little confusing. So that's why I like to put a little prime right there. Or actually, let's put a negative 1. So we'll put a negative 1 right here. So that way we know the inverse, when we get to the final part, it's this part right here. Because if you don't do that, then it looks like the original. So when you get your final answer, some people get confused. Is that the original or is it the inverse function? Okay, so make sure once you switch the variables of x and y, go ahead and put that little negative 1, the little inverse function right there. Go ahead and do that. So that way when you continue to solve for it, then you're good. Now when you solve for this, algebraically, what you want to do is, if you remember the PEMDAS, so I'm going to just go ahead and put PEMDAS here. And anytime you're solving, that's a D right there. So anytime you're solving for it algebraically, we always go the opposite direction on PEMDAS. So we always go the opposite direction this way. Okay? So when we solve for it, like the parentheses and everything and doing the order of operations, we go from P, we go this direction. But when we do it opposite algebraically, we always go bottom up. So in this first case, we're looking for, is there any adding or subtracting in this operation? So yes, there is. I have this minus 3, so I need to get rid of that first. So to do the opposite of that, we're going to add 3 on both sides. So then we should have as x plus 3 equals 2, and then the inverse right there. Okay, Next up is, do we have a division or multiplication? Yes, we have that 2 right there because it's 2 times. So we have to divide both sides by 2. So everything gets divided by 2 on this right here. So your final answer then is x over 2 plus 3 halves is equal to y inverse right there. Now you can actually keep this as one fraction. It's up to you. Or break it up. It's up to you. Okay, so that's the final part right there. So that's another way to do inverse, and this is just algebraically when we have to solve for things. Okay, now let's talk about graphically. So graphically is totally different. So graphically it looks something like this. And one of the things that we're going to do graphically to see if a graph is inverse is this definition right here. It's basically a book definition. It says if the horizontal line intersects the graph of a function more than once, then the function is not a one-to-one and its inverse is not a function. Okay? So what does that mean? So if I'm given this parabola right here, I believe in Algebra 1, we did, is this a function kind of graph? So to test to see if it's a function, you did a vertical line test. Remember doing that to see if it's a function. To see if it's a one-to-one or if it's an inverse function, you're going opposite direction, you're going to do a horizontal line test. So doing a horizontal line test then, anywhere, we can just put a horizontal line right here. Oops, it should be a little straighter. But it should be a horizontal line test. And then from the horizontal line test, if it intersects in this graph right here more than once, so for example like this one, 1, 2, then this is not a one-to-one function and it's not an inverse function. Okay, so similar to that one. Anywhere here, if I do a horizontal line test, and it's only intersecting at one point in this case right here, then it's good. It will be a one-to-one and an inverse function. Okay, so that's just basically the definition of the graph. So they'll ask us on something like this to do a horizontal line test. That's how you know when it is. Or if they ask on a graph, if it's a one-to-one or if it's inverse on a graph, this is when you would use it. Okay, and then the last one we're going to do is we're going to graph this and find the inverse function as well. So the graphing part of it, it is then given an equation, something similar to this, y or f of x is equal to x cubed plus 2. You're going to go ahead and make a chart. So it's similar to that last part that we did, I believe in last chapter 4.5. We had to graph it out. But in this case, you obviously will not have an asymptote because it's not a rational function, meaning it's not a fraction. Okay? So how do you know what numbers to choose? I kind of like to choose like from 0 and then -1, -2 on both sides of the 0. So I pretend like the 0 is my vertical asymptote kind of idea. Okay? Now, once you start graphing it, if you don't have enough, then obviously you know to use more on the left or more on the right of it. Okay? So what we're going to do then is we're going to take this, and it's similar to what we just finished off. We're going to go ahead and substitute this number right here into the original equation right here. So it's -2 to the third power plus 2. So if you do that, that becomes what? -8. -8 plus 2 becomes -6. So this is -6. If I substitute -1 into here, -1 to the third power is -1. -1 plus 2 is +1. If I put in 0, 0 to the third power is 0. 0 plus 2 is 2. If I put in 1, 1 to the third power is 1. 1 plus 2 is 3. If I put in 2 to the third power is 8. 8 plus 2 is 10. Okay? So that's this part, the first part of it. Now, you will sometimes see is this notation as well. So that's why I did the little prime. We call it a prime. It's kind of like an apostrophe kind of thing. So it's a prime up there. Okay? So that prime just tells me that in this equation, when we don't have a prime, this is the original. And if you have a prime, this is the inverse part of it. Okay? So this right here is exactly what we just did in example 1. In example 1, if this function right here or this point, because it's a dot, right? Remember we had it in parentheses? So it's the same idea. This parentheses, if it was -2, -6, right? It's a point. And we're trying to find the inverse of it. What do? We switch the x's and y variables, right? So then that gets switched to a -6, -2. Same idea with this one. We switch it, becomes 1, -1. Then we have is 2, 0, 3, 1, 10, 2. Okay, so there are two different functions on this, so be careful about that. And then from there, we're going to graph it out. So let me just put a highlighter in between it, so that way we know it's two different functions right there. So it's going to split that up for us. Okay, so we'll do the graphing as well. So when I do the graphing, I usually do one graph first, and then I do the other. So we'll do the first one, which is the original. This part right here, we'll do the original part right there, and then we'll graph the inverse. So the original says at -2, -6, we have a dot. So same thing here, -2, what was that, -2, -6, so -2, -6, we have a dot right there. Then we have a dot at -1, 1, so -1, 1. Then I have a dot at 0, 2, so 0, 2. Then I have a dot at 1, 3. So 1, 3, and then we have a dot at 2, 10. So 2, 10 is somewhere up here. Oh, wait, maybe even further up here. Let's go with this one. Okay, so what is this? Well, if it's x to the third, what shape is that? It's an S shape, right? Because it's an odd function. So in this point right here, all these points that I have is an S shape. So since this looks like it's going to be in the middle, that's kind of like the stomach part of this, we're going to go ahead and do the S shape right here. So this is going to go something like this, and then this is going to have to go downwards, right, for the S shape. So this is what the original problem looks like, okay? What we're going to do now is do an inverse function graph. So the inverse is this second part right here. So let's go ahead and graph that. So same thing, it's -6, -2. So at -6, oops, so we probably need 4, 5, 6, -6, -2. So that's the first point right there. Then I have 1, -1. So 1, -1 over here. Then I have is 2, 0. So 2, 0. And 3, 1, so 3, 1, and 10, what is it, 10, 2? 10, 2. So we have it right here. Okay, so what this graph is going to look like is this S shape is going to be reflected, okay? So it's going to look something like this, where this is still that middle part of this part right here. That's the middle part of it. So it's going to go something like this, the middle part right here. And then this part right here will be coming the other direction this way. So something like this. Okay, something like this, okay? Now, what we have to do whenever you do an inverse function is draw this line called y equals x. So y equals x, I'm going to go ahead and put y equals x. This right here is basically a reflection or a mirror line. So it's an asymptote, right? So what happens is you start at 0 and you're going to run 1, up 1, run 1, up 1. So it's going to go something like this. So run 1, up 1, something like that. So it's going to go through here. So this is the asymptote. So we're going to run 1, up 1 for all of them. So this is like the mirror line or the folding line is what I call it. And so what happens is this right here, and let me go ahead and graph the inverse in blue so you can kind of see this. So blue. Okay, so what happened is now is I took the original graph right here. This is the original graph right here. Okay, oops, it's kind of sliding there. So I took this original graph, and this is basically the folding line. So if I fold this paper in this right here, at this dotted point right here, what happens is this original right here gets folded over here, right? And then this part right here gets folded over here. Do you see that now? So that's the folding part of it, okay? So this is what an inverse graph looks like. So this is the inverse right here, and then this is the original right here. So whenever you do an inverse function, you always have to put this y equals x line right here. And it's always y equals x. So make sure you put that because it's kind of like the folding line. So if you don't have a folding line, how do you know the function is correct? So that's when you do that folding part of it. Okay, so that's what that inverse function looks like on the graphing. So you'll do two of them, which is basically the algebraically. And so that's just the switching of the x and y variables or the numbers. And then two of the graphing type. So you'll do one, which is a horizontal line test. And then the other one, which is this part right here, which was the graphing, the inverse part of it. Okay? All right, go ahead and try the My Math Lab.